Hey, Mr. Eng Math 3 students, these are Chapter 1.3 tests taken the week of December 8th, 2020. Question number 1, match the table to show whether the function is even, odd, or neither. Okay, this is talking about symmetry. And you can do that graphically. You can use a table, or if you look at what they've given us the equation. So when you're doing the equation one, right, this is what you have. I call it the star. Don't forget to sub negative x for every x. You guys remember that? Let's highlight that. Okay, so that's what we're going to do. I have two examples here. And with the magic of math, I'm going to just copy this. And then go to a space that we can work on. Okay, so we said that every x value, we're going to be putting in a negative x. Put those in parentheses. And everything else, I'll do it in black, stays the same. F equals third power minus 4 plus 3. Okay? Okay. Now, if you're unsure of your properties of multiplying by negatives, here's something you can do. This is really negative 1 to the third power. And so when I show you with my calculator, I use this one called Graph and Calc 83. I'm on an iPad. Looks just like it's free. I think it was free. And what you can do is, the common mistake is to put a negative 1 to the third power. But you want to put it with a parentheses. That's what I will show you. And to the left of the enter key on the bottom right is the negative sign. The blue buttons are the math operations. Close your parentheses, and then above the division sign there's something called a caret. That gives you the exponent into the third, and you'll see it's negative 1. So this will give you a negative x cubed. Negative times negative is a positive. Okay, quick summary of what we previously learned. If it is equal to the original, then it is an even. If it's not equal to, if it's equal to the opposite of the original, then this is an odd. That's odd. Opposite x. You guys remember that? Okay, so this one has a negative in front. So let's try to factor out a negative and see if that might change our equation. Because obviously, so let's just make sure, this one has a positive and this one has a negative. So it's not exactly the same as the original. So we can say that this is not even. Let's try the factoring out of a negative. So the opposite of a positive is a negative. And then that would be negative 3. Okay, so if you're not sure how you did this correctly, you can always distribute the negative 1. Does that make sense? And you'll get the 1 back in blue. So what's inside the parentheses there, it does not look like the same. X cubed is positive. Let's use a different color. I said a different color. Okay. Okay, that's positive. This one's negative, yes, but this one is positive, but this one's negative. Okay, so in this problem, it is not odd is not even, that would be called neither. Let's try the second one here. Magic. Cut. Put it over here. Paste. Can you make it smaller? No, can only move it. Made it too big. Okay. That's okay. Alright, let's go ahead and put in now negative x. As some students are starting to see, it's like the beauty of math. Like, you know, it's a page turner. Like, what's going to happen? You're a detective. Parentheses to the fourth power minus, that's a 2. A dying 2. Sleeping 2. Okay. So, again, PEMDAS, negative x to the fourth power, negative 1 to the fourth power is going to be negative. Negative x squared is positive x squared plus 9. And then we have negative 2x to the fourth minus x squared plus 9. Okay, so is this equal to the original? This one is positive, this one is negative, so no, it's not even. Let's factor out a negative. Negative 2x to the fourth plus x squared Hopefully, as I'm recording these videos, you guys are like, Mr. Eng, come on. And you're like screaming at me. So I guess you can scream in the classroom, but not digitally. There is my mistake. Whew, good thing we caught that. 2x to the fourth minus x squared plus 9. Now does it look like the original that I'm going to highlight here in blue, right? Positive, negative, positive. Positive, negative, positive. That is the case, so this one is even. Number 1, second equation is even. All right, let's try this next one. Number 2, place a point on each 0. If there are no zeros, leave the problem blank. You will have to click on the point until each time you want to add a point. Okay. Quick review, what is a 0? A 0, I'll just show it to you graphically, is where it crosses the x-axis. And if you had to pick a point, let's just say 4, 0, you'll see that the y value is a 0. So any point that I add here, like this one, negative 2, 0, it is a 0. Okay, so basically it's an x-intercept. They also call these roots. Okay, so we just need to add them on this graph. So I have one here at negative 4, 0. All you have to do is add that orange point. And then over here at 4, 0. Those are my zeros of my graph. Okay? Question number 3. Place a point on each local maximum. Okay. Remember, maximum, local is kind of like nearby. And then the maximum, think of a high point. Again, think of the mountains, right? Now, some students are getting confused on this part, like, okay, what happens if I consider this red one a local max? But some would say that this is the absolute max. here is my explanation to why this is both an absolute maximum and a local max. Let's pretend you live in SoCal. This red dot is the highest mountain we have. I don't know what it is. Mount Baldy or something close by. I don't know. I don't really hike. But if you lived in, like, behind your backyard is Mount Everest, then you would say this is a local max. But although it's the highest absolute maximum in the world, it's also a local max. So there, in this problem, there are two local maxes there at -1, 3. You don't need the order pairs. I'm just writing for context. And 2, 6. Okay? Okay, number 4. Describe the end behavior of the function graphed below. I think in class I told you that if you click on the blank space, then you have to look through the menu of options to look for your positives and negatives. Okay? All right. So, as a review for end behavior, you're always starting with these. And as x approaches the arrow, positive infinity. So this is the x-axis, and this is positive numbers. And this is going negative numbers. So the positive numbers is going towards the right. So this first one here is right. And the other one's going left. Now the f of x is kind of like the y values. And essentially what this is this is going to go up or down. So this is telling you how does it finish, up or down. How it finishes. Okay? And I like to use these, I would like to show you using a pen, but it's kind of hard doing that, so I'm just going to use a highlighter. So as I go towards the right, where does the graph finish? Does it finish up or down? It finishes up. And how do we say up? We would say positive infinity on the f of x. So this is another way of saying up. Okay, as I go towards the left, where is the arrow? The arrow is pointing down. How do you say down? That would be negative infinity. As a note, you'll note that this is an odd degree, right? Polynomial, because it's just like it's the easiest one, x to the first power, and they're in opposite directions, so then you have opposite signs. One's positive, one's negative. If you had an even, they would both be like positive. Does that make sense? Okay, hopefully that was helpful. Number 5. In the original function, f of x equals 2x squared minus 1 is shifted to the left 3 units to make g of x, which would represent g of x. Okay, so you have this function, and transformations, just going to write out my a times f of b x minus c. I'm going to put in a different color here, plus d. And I'm going to write the original here. So let's first annotate that in blue. So 2 x squared, and then you'll notice that the -1 has no parentheses. It's the parentheses would be on the outside. It'd be something like this. Okay, and why I'm pointing on that is that the -1 is on the outside, which is your d value. Okay. Now they're asking us to do left 3 units. Okay, this would be our c value, and this would be a negative 3, okay? Hopefully I can do this super slow and obvious, because if I put a C value of negative 3, this is what students mess up on, is that there's always this negative sign. Let me try to copy a lot of things that we have. Does that make sense? So to clean this up, you would do something like this. G of x equals 2 times x plus 3 minus 1. And do we have anything that looks like that? That would be choice number 5B. This one matches this one. So just as a quick review, this would be a vertical stretch by a factor of 2, by a factor of 2. You don't need to write this, but kind of just reviewing with you. Remember, this is the add to x, go west, so this is left 3 units. Fancy words are called horizontal translations. And then the d value here just represents a vertical translation up 1 unit. Okay? All right, number 6. Consider the following graphs. Find out which equations, so here's my 3 equations down here, that are given in the drop values. Again, those in the gray box have exactly, I'm going to highlight this because it took me a while to figure this out, have exactly the same zeros as the polynomials graphed below and drop them under the respective graphs. Okay. I'm going to make this super clear. The equations, or the functions, let's write that, it's a fancy word. Functions do not match exactly. I want to make that disclaimer because the only thing it tells us is they want the same exact real zeros. What are they talking about? All they really want to know is it matches those. Does that make sense? So let's just annotate this graph. This one has zeros. We just reviewed that. This one has zeros where x is equal to -2, x is equal to 0, right here, here, and x equals 1. Okay? Has those 3 exact zeros, 3 zeros. This one has zeros at x equals -1 and +1. Okay? So let's take a look at this one in green. Rewriting the problem. Okay, so if I factor out a GCF of an x, because they each have an x, then I'm left with x squared plus x minus 2. And then here in yellow, I can factor it. So this would be a times c would be -2, b value is 1, 2 numbers are +2, and a -1. So we have x times x plus 2 and x minus 1. And then if we apply the zero product rule, we're just going to set each of those equal to 0. set each of those equal to 0, not including the parentheses, and then you'll notice that you already have an answer here. And you have x equals a -2 and x equals 1. Okay, so this one has 3 zeros, 0, -2, and a 1, and that matches the graph number 1. So I'm going to copy the one in green here into the first graph. Okay? All right, let's do this one in, oops, wrong tool, purple. Let's work on that over here. Y equals x to the 4th minus x squared. Okay, let's do the same thing. I notice they both have an x squared, so I'm going to factor out a GCF of x squared. And you'll be left with x squared minus 1. Remember, you can distribute to check your answer. Okay, so same thing. You can add a 0x in there. And then factor a times c inside the parentheses would give us a -1. B value is 0, so that's +1, -1. So right there, I just factored. And then you set each of those equal to 0. And then take the square root here, so you get x equals 0. Subtract 1, x equals a -1, and add 1 here, and x equals 1. So which one of these has a 0, x equals 0, -1, and +1? That is actually right there. So this would be x equals 0. So this one would have graph 2. And then this third one, let's do it over here. Why did I? It should be purple. Can I change it to purple? Cool. That was so cool for me because that was the first time I ever done that. So it's cool. Y equals x to the 4th plus x to the 3rd minus 2x squared. All right, I'm going to do the same thing. I'm going to factor out a x squared. So x squared plus x minus 2. And then we're going to factor here. A times c is -2, b value is +1, so 2 and 1, positive and negative. +2 times -1 is -2, and 2 minus 1 is 1. So +2, -1. So x squared, x plus 2, x minus 1. And then we're just going to apply the 0 product rule here. X equals 0. Set each of those equal to 0. That's already solved. Yay. Subtract 2. X equals -2 and x equals 1. So which one has 0, -2, and 1? That would be graph 1. So I'm going to copy and paste that one. So again, when I'm putting it under here, it's not matching the exact graph, it's just matching the zeros. Probably make that question extra credit because didn't teach you entirely, but if you can get it, I'd be super happy. Okay, question number 7. Given the following polynomial, you'll notice that it is factored, okay? they're asking about the zeros. The zeros are already here. And the multiplicity refers to the numbers on top. Those little numbers. That's what multiplicity is. Remember, it's kind of like you go shopping and I wish I could buy some Jordan shoes. And this is say like I got a big pay raise and maybe I want to order, I don't know, 6 pairs of Jordan shoes. The same exact ones because I want those for the rest of my life. And so the quantity in which I order it is like multiplicity. Okay, so the multiplicity for -5 is 2. And the multiplicity for x equals 3/2 is 5. Okay, how did I get those? How do you go from these binomials in blue to those over there? How do you go from there to there? Okay, well, you're just setting those equal to 0. So x plus 5 equals 0, and then you would get x equals -5. So this is a big idea, guys. The parentheses, x plus 5 set equals 0, is the same thing as x equals -5 here in purple. X equals -5. They are both zeros. So the black and the purple are the same. Okay? And then let's do the other one. I have 2x minus 3 equals 0. Teach you my little trick. In PEMDAS, you're going down to simplify, but when you are solving, you actually go from the bottom to the top. So you would not divide by 2 here. You would add 3. And then you could divide by 2 and x equals 3/2. Okay? So that's how you go from the binomial to an x equals. Again, they are both zeros. Okay, state the each zero state its effect. So our options are bounces. In our class, we use something called a kiss. In intersects, we call this one shoot-throughs because it shoots through the x-axis or it kisses the x-axis. Okay, so here in purple, this number is an even or an odd. 2 is even, and evens kiss. So x equals -5, its effect is a bounce or a kiss. This one. 5, is it an even or an odd number? That is an odd, so it's going to shoot through or intersect. Just because we have this all up, I'll just graph this really quickly, super fast. X equals -5, x equals 3/2, and coefficient is positive. 2 plus 5 is 7, so it's an odd, so you're going to start down and up, and at -5 you are doing a bounce, so bounce here. It's going to go through some super low number, and then at 3/2 you will shoot through, something like this. And the magic of math, you can just make the things thicker and something like that. Ugly, but gives you the idea what's happening to the graph. All right, number 8, analyze the functions. Okay, in the functions, which function has a greater degree? The degree is you're looking for the highest exponent. So this is my degree. So this one has a degree of 3. Okay. They call this one a cubic. Now, let's look at this graph. The second one on the right side, I have just table of values. So what I'm going to do is I'm going to graph it. Let's graph it. So -1, -2, 1, 2. Count by twos. 2, 4, 6, 8. And let's just graph this. -2, 7. Left 2, up 7. -1, 1. 0, -1. No, here. Let's erase that one. And 2, 7. Well, what does that look like, guys? That, my friends, looks like a quadratic. Second way you could have told is something we learned previously, so I'm showing you a second way of verifying that this is a quadratic. You have a subtract 6, subtract 2, add 2, plus 6. So that's your first common difference. And then that would be a -4 minus plus 4 plus 4 plus 4. Second common difference is quadratic. So two ways to verify that this is a quadratic. So which one is the greater degree? My choice would be this one. So that would be P of x. P of x is greater because R of x is a quadratic. And so those are mine for the chapter 1.3 test. See you guys.